Hello, everyone. Today I'm going to talk about a project I've been working for the past few days, that is predicting telco customer churn. So let me tell you a little bit why this is important and why this is relevant. As you may already know, nowadays, it's really straightforward for customers to change internet or cell phone providers. That is why telco companies need to keep the customer engaged and prevent them from churning. So the question we came up with was, is it possible to predict the telco customer churn using supervised learning models? Well, the short answer for that is yes. And let me show you my approach. For analyzing this question, we chose a dataset from Kaggle. This dataset has around 7,000 rows and 19 featured columns. 17 are continuous columns and 2 of them are categorical. The dataset also has only one binary label, that is yes or no, indicating if the customer churn or not. As we're using supervised learning, we also split the dataset into train and test, using 85% of the data for train and 15% for test. Also, as the data is unbalanced, we need to take in consideration that only 20% of the samples are churning customers. So we needed to use a stratified split to make sure we have the same proportion of each class in train and tested. Following on, which models did we try? Well, we started with some simple models such as logistic regression, and then we tried random forest and gradient boosting. Let's start with data preprocessing. We decided to separate the preprocess into two different parts. One categorical column and another, one for categorical columns and another for continuous columns. For categorical columns, we simply apply a one-hot encoder transformer. However, for the continuous columns, we apply simple imputer to fill the null values using the future column mean. And after that, we apply a standard scaler to have all of our features on the same scale between -1 and 1. Going on with this, after performing all the preprocesses mentioned before, it's time to fit the models. In order to choose the best hyperparameter for each model, we perform randomized cross-validation search using a total of 5 folds with 125 iterations over the grid. This means that we fit a total of 625 models for each algorithm. After fitting all these models, another important question is, how are we going to evaluate these models? As we mentioned before, this dataset has unbalanced classes. That's why we will use metrics such as F1 score, average precision recall, and balanced accuracy. The three of them are really useful for handling unbalanced label distribution. The first model we trained on was logistic regression. This is one of the simplest models that can be used from binary classification. And with this model, we got an F1 score of 0.56, balanced accuracy of 0.72, and an average precision recall of 0.69. Furthermore, moving to a more complex model, we use random forest, and we got a slightly better F1 score and balanced accuracy score of 0.75 and 0.73, respectively, but a lower average precision recall of 0.66. Finally, we trained a gradient boosting model. This model got the three highest metrics, F1 score of 0.65, balanced accuracy of 0.75, and an average precision recall of 0.69. So at this moment, you may be wondering, which is the best model, right? Well, as it was shown in the previous slides, the gradient boosting is the best model, as it has the best three metrics overall: the best F1 score, the best balanced accuracy, and the best average precision recall. After fitting and choosing the best model, we also decided to perform permutation feature importance algorithm over the dataset. We found that the 5 most important features are contract, total charges, tenure, internet service, and online security. These insights are really important for the business as it may give them some interpretability over the model. Following on this, we have some conclusions and some business recommendations. First of all, although the gradient boosting is the best model, the free model that we tested have a really good performance. Also, we can give the business a recommendation, and they can set a threshold using a threshold in the model of 0.19. They will be able to predict 90% of the churning customer. This means having a 90% of recall with a precision of 47%. And also, one important thing to mention is that this threshold can be modified according to the business necessities and according to what the company is looking for, such as more recall, less recall, more precision, or less less precision. And as next steps, we should discuss the business expectations regarding false positives and false negatives. And also, it will be great to try a model ensembles to see if we can improve our model performance.